Hi, this is Mr. Beck Does Your Homework. This is homework number 12 on Springs and Hooke's Law, questions 4 and 5, a two-part problem. Question 4 says a 0.465 kilogram mass is attached to a spring with a spring constant 154 newtons per meter. Let me actually stop there and write down those values so I know that the mass equals 0.465 kilograms and the spring constant K equals 154 newtons per meter. Okay, so that the mass is allowed to move on a horizontal frictionless surface. So now we need a horizontal frictionless surface. So this is going to be my table. And we'll just have a place to attach the spring over here. And so I have the spring, and it's attached to the mass there, M. The mass is released from rest when the spring is compressed 0.162 meters. The spring is compressed. When a spring is compressed, that is X, the amount the spring is compressed, and that's going to be 0.162 meters. So that means that the spring, we're going to have pushed it back by a distance. Let's assume that this was the original length of the spring here on the right, and now the spring has been compressed this distance, 0.162 meters, so we'll just call that X. The first question is find the maximum force on the mass. Well, when you compress the spring to the left, that means the spring is going to be pushing back to the right with a spring force. And that spring force is going to be the force that's acting on the mass from the spring. So you've compressed it to the left, the spring is pushing back to the right with a certain amount of spring force. And the way to get that spring force is to simply calculate using Hooke's law, that the force of the spring is going to be the spring constant times the amount the spring was stretched or compressed. So for me, that force on the spring is going to be the K of 154 newtons per meter times the distance it was stretched of 0.162 meters. And it's always good to check the units that you have. In this case, I have meters and meters, so meters is going to cancel out, leaving me newtons as the answer. So that would give me an answer for the force of the spring. For me, it's 154 times 0.162 gives me a value for the force applied to the block by the spring. That would be the spring force. So that would be the answer to question number 4. Now question number 5 says find the maximum acceleration. Well, where do we get acceleration in all of this? Oh, of course, Newton's second law that tells me that the net force is going to equal the mass times the acceleration. So the acceleration is going to be the net force divided by the mass of the block. The net force is going to be that maximum spring force when the spring is most compressed. When you release the block, that's going to be the maximum force. That's going to give you the maximum acceleration. So that acceleration is going to be the spring force up here, which you get from your value earlier, divided by the mass, which we hear, for me, it's 0.465 kilograms. So you put the mass there, and then you will get a value for the acceleration for question number 5. And it's in units of meters per second squared, and that will be because it's newtons divided by kilograms, and a newton is a kilogram times a meter per second squared, so the acceleration will be in the proper units of meters per second squared. And that's question 5.